Greetings. Today we'll be demonstrating the Osborne Reynolds apparatus. The objective of this experiment will be to observe and calculate the Reynolds number for laminar, transactional and turbulent flow. The equipment required are the Osborne Reynolds apparatus, a measuring beaker and a stopwatch. This is an Osborne Reynolds apparatus. A total of 13 components make up the Osborne Reynolds apparatus. Let's look into all the 13 components. Now as we start from the top, this is where you will find the dye reservoir used to store the dye. Just below that is the dye flow control valve that is used to control the flow of dye. This is the height adjustment screw that is used to adjust the height of the dye injection into the tank. Now this is called the head tank. If we look closer, you will find the hypodermic tube coming from the dye reservoir and injecting the dye into the small opening called the bell mouth entry. This bell mouth entry is then surrounded by glass marbles, as you can see here. Now coming around, this is the overflow pipe. It is used to control the level of water inside the head tank. This is the test section. It is used to observe the different types of flow, whether it might be laminar, turbulent or transactional flow. This is where you will observe it through this pipe. This is called the inlet pipe. This pipe brings the water into the tank. This pipe it is attached to a water supply. Now at the bottom is the flow control valve used to control the velocity of the water coming from the apparatus that is exiting the outflow pipe. These are adjustable feet used to balance the apparatus, and at the end keep your stopwatch handy to note down the times. These are the different components that make up the Osborne Reynolds apparatus. Okay, so let's set up the Osborne Reynolds apparatus so that we can get the readings from the experiment and find out the Reynolds number for the different types of flow. Here the first step will be to connect the inlet pipe to a continuous water supply such as this tap, and we will just screw this on to the tap. Okay, now it's screwed on tightly and be sure of that. Now turn on the tap and let the water flow into the head tank. Now the water that has to be filled in the head tank has to reach the level of overflow pipe. uh, it is suggested that the water level be at such level continuous pace coming from the inlet pipe that a little amount keeps outflowing from the overflow pipe and a certain level is maintained into the head tank. Okay, the tank is almost full. We are just waiting for the water to reach the overflow pipe level. Yeah, okay, that seems good. Now let's turn on the outflow control valve, the flow control valve at the bottom. This will maintain a continuous flow of stream of water coming from the tank towards the outlet pipe and into the tray. This is necessary to make a continuous flow so that the water flows from the head tank and to the outlet. Now let's pour the dye into the dye reservoir. Be careful while pouring the dye into the dye reservoir. Spilling the dye won't be good for anyone. Okay, that seems good. Now in order to control the flow of the dye, let's turn the flow control valve and inject the dye from the dye reservoir into the head tank. As you can observe, the dye is being released into the head tank, or you could say into the bell mouth opening. This dye then travels from the bell mouth opening down towards the outlet pipe. The dye is used for indication of the different types of flows. Let's adjust it a little bit more. You need to observe the dye coming in the test section. This is where you will observe the different types of flow. So a continuous stream of dye along with the water needs to be observed in this section. We are going to adjust the height of the hypodermic tube using the height adjustment screw just a little bit so that we can observe what. Yeah, this is the screw, and we just adjusted the height of the hypodermic tube a little bit. As you can observe, there is a continuous stream of dye coming from the tube, and that can be seen in the test section as well. A continuous straight line of dye coming in the test section. This is how you set up your Osborne Reynolds apparatus. Recheck whether all the components are working properly. And a word of caution, do check that your system doesn't have any bubbles, because if a bubble is being formed into the whole flow process, then it may affect the results in the end. Now that you have set up your apparatus, we can move on to taking the readings. First, we'll be taking the readings for laminar flow, in which, as you can see in the test section, there has to be a straight line of dye, and that indicates that the flow in the test section is laminar. Now, in order to take the readings, you will have to measure the time taken by the water that is coming out of the outlet pipe, which will be collected in a glass beaker such as this. In this test, we will be measuring till 100 ml of water, and we will measure the time it will take to uh, to fill 100 ml of water in this glass beaker. So let's take the outlet pipe out from the drain, and let's start the stopwatch to. Okay, let's observe the level of water in the beaker. It's 100 ml that we have to fill it till. Okay, that's about it, and the time taken is about 13 seconds. Okay, fine. Now, in order to take another reading for the laminar flow, we would increase the velocity of the water coming from the head tank, and that can be seen in the test section. So, in order to do that, adjust the flow control valve. Slowly turn it to increase the velocity of the outflow water, and you will notice a difference in the dye as well in the test section. We have achieved a continuous stream of dye in the test section, as it can be observed. Now let's drain the water collected in the previous reading and set it up for new reading. In this one, we will take 200 ml of water in the beaker and measure the time taken for it to reach that level. Let's start it, and let us observe the level of water. That is about 200 ml, and the time taken for it is 18 seconds. Now we can move towards measuring the transactional flow. In order to measure the transactional flow, we have to adjust the flow control valve, and then we will observe some difference in the test section of the die flow line that is seen in the test section. As you can see, let's adjust it slowly and we will observe the test section. For transitional flow, we are looking for a flow which is both laminar as well as turbulent in nature. So, a laminar flow that is turbulent as well is what we need to observe in the test section. Let's see. Yes, yeah, we can now observe some transitional behavior in the die line. So this seems alright, and then we can move ahead to take readings. So let's drain the glass speaker again and set it up. We will be measuring the time taken to fill 300 ml of water in the beaker. Let's observe the level of water. And that's about it. The time taken to fill 300 ml is about 14.03 seconds. Now, in order to take the second reading, we will keep the setup as it is, and we will drain the water in the beaker. For the next reading, we will be taking 500 ml of water in the beaker and noting down the time it takes to fill up to that level. So let's take the outlet pipe and start. Let's notice the level of water in the beaker. And that is about 500 ml, and the time taken for it is around 23 seconds. So this is the reading for transactional flow. Moving towards turbulent flow, let's increase the velocity of the flow using the flow control valve such that the flow becomes turbulent. That can be observed by the ink jet in the test section. Okay, now that's done. Let's take the outlet pipe and measure the time taken for it to fill the beaker. We'll be taking 400 ml. The time taken, we'll be observing the time taken to fill the beaker till 400 ml. So let's observe. It's almost 400, and that's it. The time taken for it was around 53 seconds. Now, in order to take the second reading, we'll keep the setup as it is and drain the water in the beaker and set it up for another reading. Let's take the outflow pipe and start. This time we will be taking 800 ml of water in the beaker and observing the time taken for it to fill up to that level. Okay, it's about time, and that's about 800, and the time taken for it was 2 minutes and 15 seconds. So this is the Osborne Reynolds apparatus and the different readings for the different types of flow.